All right, Samantha. So, STEM for girls.
Mm-hmm.
Woo!
Part 5?
Right?
4 or 5? I can't remember. 5.
So now we have this microcontroller brain, and it's all hooked up to this guy. And what we did is I found the code online for how this guy works. We have to send a digital plus or minus to one of these guys, and then the other guy, and it'll toll forward and backward. And then the other one, we do an analog write, and we analog write our motor speed. You see here, analog write. So, what does that mean? It means that one of these digital ones, the one that we use for analog, has to go to one of the A's. So let's go and let's put that on
So
A0.
you just messed up.
So we want to put it on A0. It's okay. We didn't mess up. We made a productive movement forward. All right. So in here we have A0, right? So on EN1 I'm going to put A0. All right. And then on ENA is going to be 0. So A0. Let's just write A0 there. So you can't write it in.
And so we have a cord hooked up to this little piece right there.
These two chords are now on D11 and D12, right? So I'm going to put in this code, Samantha, look over here. D11 and D12, okay? So now, the Arduino is a simple, tiny little machine, and he goes and he's in a setup, and he runs this code, and then he goes to the loop, and then he keeps looping forever. When we got this guy, he had a loop code, and all it does is blink. You see how it's blinking right now?
Yeah.
Let me show you that blink code. So this is what's running right now on the Arduino. Is running, and you don't have to worry about all this garbage here. We have just one thing going on in the setup, okay? And it says pin mode LED built-in, which is the LED built-in wherever that is. It's probably pin 13, right? And then it says it's an output. So it's going to send the output data. And then in that loop, it says digital write to the LED to go high. Then delay for 1,000 milliseconds. So this computer, he counts. How fast can you count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Count.
1, 2, 3, 4, 5, 6, 7, 8.
Okay, this guy can count to 1,000 faster than any human can ever count. He can count to 1,000 in 1 second. 1,000, okay? So this is 1,000 milliseconds. Okay, 1,000 milliseconds. So when we wait for that, this is 1 second. See, high, wait 1 second, low. Digital write low, wait 1 second. High, wait 1 second, low, wait 1 second. So it's actually looping the code right now, okay? So let's change this to, instead of 1,000, let's change it to 500. What's gonna happen?
In like half a second.
I'm gonna say now, I'm going to find the Arduino. I think it's gonna be in Uno. Or we're gonna call it a Nano.
Dos, tres.
Let's go to Nano. This is an Arduino Nano. And we need to say it is the Atmega 168. Oh man, I can't read that from here. 328. Okay, we're gonna leave 328 and then the port. Now, we gotta choose the guy. Bluetooth. I think it's this USB serial port. So if we unplug it and we don't see him anymore, we know that's the one. And then I plug it in. Almost there, kiddos. Alright, so it is there. It's the USB serial port. Alright, so I'm going to upload this code with the command U, sweetheart. Upload. And now it's going to find this code and it's going to start talking to it. So now look how it's blinking. You see the blinks? It's uploading the code right now. Alright?
Cool.
It's uploading. Programmer's not responding. Attempt 1 of 10. So let me do a reset to see if I can fix that. So I did a reset, right? To see if I can get it to force itself to attempt it. It might be I have the wrong... Maybe I have to do Arduino Uno. Alright, so... Something didn't work right now. Let me see the simulation. 8 VRs... Arduino, right? gonna try the Uno. Let's see. Upload. Problem uploading to the board. I'm sorry, sweetie. I should have done this. Let me try the Uno.
And Dad, we haven't showed our cameraman.
Done uploading. Okay. You see how it's blinking faster? I had to switch it to a different board type. This says Nano, but I switched to Uno and now it works. So you see how it's faster? What is going to happen if I do 100 for the nanoseconds?
It would be like a quarter of a second.
Bum, 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 bum. It's a tenth of a second. And now if I do, and I take away the delays, it's going to go so fast, it's going to be a blur. We won't even see it anymore. It's going to be just like at half on. You see how it's sort of on? This is half on. It's vibrating so fast, our eye only sees some light. Watch this. I'm going to delay instead. I'm going to delay to 10. You're going to see it. Maybe you'll see the blinking.
Yeah.
You still can't see it. When you see the red pulses over here, it's when the computer's talking to it. So let's do 50 because 10 was too fast for our human eyes to see, but not for the camera. You see how you can see the blinks at 50? Now I'll do 20.
Now do it to 2,000.
2,000, okay. I'm gonna do it to 2,000. 2,000. That's 20, by the way. 20 milliseconds. Now I'm gonna do 2,000 like you said, and it's gonna be 2 seconds in between each one of those. 1, 2, 1, 2, 1, 2, 1, 2. Okay? Alright, so now that we know that we can talk to our board, now I want you to do this. We're going to take the motor demo code here, and we're going to make the motor treads spin. So what we're going to do is we're going to say in the setup, pin mode output, right?
Mm-hmm.
And then I want analog right for A0, which is the one we plugged in here, and I want to set it to 200. And then I'm going to digital right low and high, and then it's going to reverse. It's going to digital right high and low. So we're going to do high low, which means just go to 5 volts and then go to ground. The black wire is ground, the red one is 5 volt, and then we're going to switch it. Let's run this code and see what happens. The red stuff, so you got it? All right.
Yeah.
Done uploading. Uh-oh.
7 minutes, 47 seconds.
Okay. Now we got to figure out what happened. Oh, that's right. I have forgotten a jumper wire. I need to do a jumper because of the fact that this motherboard, it was wondering if we were going to get logic supply, and we didn't give it logic supply, but it has an onboard logic regulator. I'm sorry. I need to plug this in here. That was my fault. Now, your code is now doing this, Pumpkin. You just put code onto this brain, and now it's talking to this heavy lifter, which is your living room, right? And now it's turning this. Do you want to make it go faster or slower? Let's change the 2,000.
Faster.
Let's do faster at 500.
3,000.
3,000. So it's gonna go for 3 seconds. 1, 2, 3, 1. Now let's see if we can make it go faster. Let's try the motor speed of
10 seconds.
I don't know what 1,000 does. Let's see what happens. Maybe 255 is the maximum for the motor speed. Let's look on the website. Let's find out. So this is the motherboard for this thing, right? And then they have the sample code here. But they didn't tell me what was the analog value for the... Maybe, I think it's 255. Okay, 255. It's a bit number. It goes from 255 all the way to 0. So if we wrote 100, it should be half motor speed. Yeah, 255 was the max. Sorry, kids. So this should be half speed.
Did the robot explode?
Probably it did.
It didn't like 200 at all. Let me go back to this number, 200. Let me try 300. Let me see what happens with that one. Let me try 10. Hmm. 255. And there you have it. It looks like it's only on off. I don't see a speed control that's going on, but it should have a speed control. We'll tune in next time. We'll figure it out, and we'll try to get this guy.
In part 6.